All right, in this video, we are going to do an introduction to integration by parts, and I'm going to include both the formula and what's called tabular method. Here's the formula. It may look kind of wild, but just don't even worry about it yet. We're going to show you where that comes from. Before we do anything, I need you to do a handful of things to make sure you're ready to learn and really understand this integration by parts. I got three integrals. Cosine x dx, x cosine x squared dx, x squared cosine x cubed dx, plus I want you to take the derivative of this thing right here. Couple little hints. Should be super simple. Just need to make sure you are integrating the correct trig function as opposed to sine. Keeping track of your negatives or not. Little u sub, another little u sub, and some product rule. So please pause and go ahead and do all of those integrals. Here come your answers. Hopefully you've paused already and done all those. All right, so here's some answers for you. First off, reminder, cosine, or the derivative of sine is a positive cosine. The derivative of cosine is a negative sine. When I integrate, I go backwards. So we're integrating cosine right here, which means we're integrating from this back to that. So we do wind up getting a positive sine of x. All right, so next one here, x cosine x squared. Well, I'm going to make my u equal to cosine, or u equal to x squared, and then my du is equal to 2x. Then I can sub these guys, or I take the 2, I divide by 2. I get a half of du is equal to x dx. So the x dx will get replaced, and the x squared will get replaced. That simplifies down to 1/2 cosine of u du, which then gives me 1/2 sine of u plus c, which I then go and plug in the u as an x squared. I'm going to get 1/2 sine of x squared plus c. This next one's real similar, except for it would give me a 3x squared and an x cubed and 1/3 integrate. I wind up getting 1/3 sine of x cubed. The key here with these two is that this piece right here and then this piece right here both match their u sub parts, right? So the u and the du work, okay? Integration by parts is going to give us a solution for when the u and the du don't work. All right, so come down to here. This should be pretty straightforward if you remember your derivative rules. The derivative of x times cosine x is product rule. F times g, if I prime it, is f prime g plus g prime f. You should be familiar with that. So it's the derivative of the first, which is 3x squared, times the second, cosine x. And then the minus comes from the derivative of the second, which is negative sine x, times the first, x cubed. All right, so hopefully you are good with those, and we are ready to learn integration by parts. Okay, so let me scroll down here. I am going to give you an example of an integral that we can't do with u sub. Integral of x times cosine of x. That one, the u sub doesn't work out. If I make u equal to this, I don't get a du equal to an x, so we run into a problem. Oh, I should put a dx. So this is one for which we can use integration by parts. Before I show you that, I'm going to give you the formula for integration by parts. So we'll flip to this. So to do that, or to give you the formula, it's the integral of u times dv, I'm trying to make my u's and v's look different, is equal to u times v plus the integral of v times du. So some people remember this as ultraviolet voodoo. Ultra for the u, violet for the v, and then voodoo. And I actually made a small error. I am going to fix this. It's minus the integral of v du. Very important. So the integral of u dv is u times v minus the integral of v du. So I'm going to show you why this formula works. It's pretty straightforward and easy. And then we're going to show you how to do one example. And then we're going to try and work our way into doing it in a little bit easier way. So let me first convince you, hopefully, that this has to be true. So what I'm going to do is I'm going to start with u times v. And just a little hint or connection. The reason I had you do product rule up here is because of what we're about to do. So say I had the integral, or say I had u times v, but say I wanted to derive it. I'm just going to say d for derive because it seems to work out and is not super messy. For this, well, it would be the derivative of the first. What is that? Du times the second, which is what? V. That's the first part of product rule. Plus the derivative of the second, I'm going to write that as dv times the first, that's u. So from here, I'm just going to change the way that I have this written. And actually, before I do that, I'm just going to write this in a little bit more familiar way so that you can make the connection. But if I write u times v and I want to prime it, that would be u prime times v plus v prime times u. That's what product rule says. And I'm saying the same thing in this line right here. I'm just trying to do it with a little bit different notation, and I think you'll see why. So, let me then, what I'm going to do is, you all should know how an integral and a derivative are related. They're opposites of each other. What I'm going to do is integrate both sides of this line right here. So what I'm going to get is the integral of the derivative of u times v is equal to the integral. And here's one thing I'm going to do when I take their integral. I'm going to switch the order of these two. So, doink. Integral of v times du. So I just switched the order of these two right here. And then plus the integral of, you guessed it, u times dv. So from there, I look at this and I say the integral of a derivative. What happens? Oh, they cancel. Cool. So that gives me u times v is equal to, and the other side's going to stay the same, integral of v times du plus the integral of u times dv. So this is looking familiar, and I'll zoom out a little bit. It's almost this exact formula that we have up here. So what I want you to see is that I can isolate this side right here by just subtracting that integral and putting it over on the other side. And then I can switch to the sides that they're on. So what I wind up getting is this piece, integral of u dv, is equal to this thing, u times v, and then minus this integral right here, integral of v times du. Now you may be like, okay, sure, right? What does it mean? Well, we're going to show you how to use it and what it means, but I want you to be convinced that it actually is true. So we just use some logic to use some product rule to take some derivatives and then solve for one thing, whatever, right? This is your integration by parts formula. And it's the standard way that it's written in books and on the internet or whatever, always with u's and v's. So let's go ahead and use it. All right, we are going to go do that example that I showed you earlier. So integral of x times cosine of x dx. I'm going to integrate this using integration by parts. And you'd be like, well, what? Right? Just roll with me. I'm going to color code everything for us here. So, and I'll also pitch that the decision-making process that I'm about to go through right now is not something that we expect you to be able to do off the bat. I'm going to show you how this formula fits doing this integral. And then as we get good at this, you will learn what goes where, and we've got all kinds of tricks to make this easy. So this right here is my x. That's going to be the u. And then we'll flip over to blue. So the cosine of x dx is going to be the dv. And then I may as well go ahead and color code some things as well. If this is u right here, then here's another u. Oops, pause. Let me switch to a color that matches that one. There, that's the u. And then that's good for now. So what I'm going to do is go ahead and write u equals, well, what did I say u is? U is this purple right here, which is this purple right here, which is x. So we can go ahead and highlight that. So that's my u. I can actually go ahead and write equals x times, because if I've got the integral of purple, then this, and purple, then this, and purple is the u, so that's where this shows up. That is that piece right there. So what I want you to see here is that I've got a du here. So what does du mean? It means take the derivative of u. So what is the derivative of u? Well, the derivative of that thing is 1 is what we like to think about it as, but I'm going to write it as that it's equal to dx. And you should be used to that kind of work from u sub. So since I'm taking the derivative of both sides, I had some weird technical difficulties there, but since I'm doing the derivative of u, I get dx. You should be okay with that. So now what I'm going to do is come in and we're going to highlight that. Here, right here is what's du. It's dx. And notice I get a du right there. So that's going to show up over there, and I'll fill it in later. Okay, so then look. Notice I have dv right here. So what I can do is write that dv is equal to, because dv is the blue is right here. So what I'm going to get is that it is cosine of x times dx. And now, just like when I had u, I took the derivative to find du. I've got dv, and I'll make that a better v right here. Notice I've got a v on the right side of my formula. So what do I need to go to get from dv to v? You guessed it, I integrate. So when I integrate that, I get that the integral of dv, that gives me v, is the integral of cosine x dx. Well, what's cosine integrate to? We just did that a moment ago. It's sine of x. Typically, we don't write the plus c, and there's reasons for that, but I'm not going to get into that right now. I will go ahead and highlight some things here. We've got, so I'm going to make dv, or I'm going to make v yellow, which will make that yellow. And then I'm going to make I'm going to add this guy to be blue. Here, right here. Oops, there we go. Okay, so what I want you to see, so this is V, so that is also going to be yellow. All right, so what do we get? Notice I get U times V. I've already got the U. It was the X. Remember, this feels crazy, right? But trust me, it's super useful, and we will make it super easy. I get u times v. V is sine x. I can highlight that as yellow so that it matches all of our color coding. And then I get minus the integral of v, which is, again, sine x. I'm pulling that from this formula right here. And I'll highlight it in yellow. Times, all right, what's the green? The green is my du, and notice that's down here. That actually works out really nicely because I need that in order to do my integral. So we'll pop and write this as green. And hopefully you should see how all these colors line up with pulling things from here and integrating, deriving, and then just plugging them in. So what do we get from there? We get equals, all right, x sine x minus the integral of sine x dx. So you should know how to integrate sine x. This leaves me with x sine x minus sine integrates to a negative cosine x, and it gets a plus c. And then I get two negatives there. So what do I get? I get x sine x, double negative gives me positive, and then a cosine of x plus a c. I said earlier that we don't do the plus c. Where was it? Right here. And that's because it really gets accounted for there. So, all right. Feels odd, but that's the integral to this thing. You could take the derivative of this to double check it, and you would see that it derives to what we started with. And it becomes a really, really super useful tool for doing integrals that we would otherwise not be able to do. And again, I will show you in the next video how to do this easily. All right. See you there. Bye.